All right, here's a fairly straightforward CELO theorem application exercise, as well as just solvable group fact checking, like making sure you know how solvable groups work. But anyways, prove that every group of order 162 is solvable. The first thing you do is you break it down into 2 times 3 to the 4th, which is just math, like the boring, no, arithmetic. I think usually when people who don't know what pure mathematics is talk about math, what they really mean is arithmetic, and that's what I'm referring to here. Just like adding and multiplying numbers. Anyways, we know by the CELO theorems. Of course, I wrote this theorem 6.3 here because this was for a take-home midterm, and we had to reference the theorems that we had in class and notes and stuff. And so I did it way overly much just to make sure that I avoided losing points. And so yeah, if you're curious what that M stood for, it stands for midterm and not for math or something else like that. Anyways, CELO theorems tell us that N3 must divide all the terms that, or the product of the factors that don't involve 3, and so that's just 2, and it's also equivalent to 1 mod 3. So what possible numbers are there? Not a lot. The only one is 1. So then there is only one CELO, we have only one CELO 3 subgroup, and we'll call it P. P is the unique CELO 3 subgroup, and it has order 3 to the 4th, which is 81. And then we know that G acts transitively on the collection of CELO 3 subgroups by conjugation, and that's true for any, not just for, that's true for any prime. Action by conjugation is transitive. But since we've only got one CELO 3 subgroup, conjugating P by any element is going to give you P, and so P is normal. This is a very standard trick in these CELO theorem problems, is that if you've got only one CELO P subgroup for some prime P, then that subgroup must be normal. So anyways, we've got a normal subgroup, so that's nice. So the size is 3 to the 4th, so it's a 3 group, obviously. Now, by corollary, I don't know. P groups are solvable for any prime P. And that's like, whenever I state these theorems here, it's always obvious what the theorem's supposed to be. So here, the theorem is obviously, or the corollary is obviously, that P groups are solvable. And so this P here is a P group. It's a 3 group, and 3 is prime. So it's a P group, so it's solvable, and so P is solvable. Alright, so what about G then? So let's look at the quotient. The quotient is obviously going to have size 2, and so the quotient is isomorphic to Z mod 2Z. That's a 2 group, and 2 is prime, so obviously this is going to be solvable. However, note that we've got this means that we have a normal subgroup such that both the subgroup itself and the quotient are solvable. And we know that that implies that the overall group is solvable. And so therefore every group of order 162 is solvable. So this group, much like this problem, is solvable. And I'm sure that joke has never been made in the history of math. But anyways, we're done with this problem.